A wireless charger that sits under your skin could power medical devices before dissolving into your body. The wireless charging device can power implants and other devices by moving energy wirelessly through the body or harvesting energy from the body itself. Scientists have created a wireless charging device that could be inserted under the skin. So far, it's only been tested in rodents, but if follow-up research in humans is successful, it could mean medical implants ditch and clunky batteries and wiring that could come with them. Most bioelectronic devices, such as sensors or drug delivery systems, are often limited by the capacity of onboard batteries. They can also often be hooked up to an external power supply, but this risks causing infection, specifically if the patient needs surgery to remove the replaced parts. To get around this problem, scientists built a prototype wireless charging chip that can be embedded under the skin. The prototype, tested in rats, can either wirelessly transfer energy through the body or harvest energy from your body. The flexible and soft under-the-skin chip can also adapt to the shape of tissue during a procedure, and it's biodegradable, researchers wrote in a paper published November 15 in the journal Science Advances. Our prototype power supply system represents an important step forward in advancing a wide range of biodegradable implantable medical devices with its potential to provide effective and reliable energy solutions, study co-author Wei Lan, professor of electronics in the School of Physical Science and Technology at Lanzhou University in China, told Life Science. The prototype power supply uses a magnesium coil that charges when a second coil is placed above the skin. Power passes through a circuit and then enters an energy storage module made of zinc-ion hybrid capacitors. Unlike batteries, which store energy in chemical form, these supercapacitors store power as electrical energy. They also have a high power density and can discharge a large amount of energy at once, even though they store less energy per unit than batteries do. The researchers embedded this prototype in a biodegradable chip-like implant that combined energy harvesting and energy storage. When the prototype was attached to a medical implant, power passed through the circuit directly to the device and into the capacitor to ensure a constant power supply. In rats, the wireless implant worked for up to 10 days and dissolved completely within 2 months, proving its biodegradability, but it could potentially last longer if the team thickened the protective polymer and wax layers encasing the system, Lan said. The researchers also tested the wireless charger as a drug delivery system and delivered anti-inflammatory medicines to rats with a fever. After 12 hours, the rats had no implants, had much higher body temperatures than those with the chips, suggesting the device was successfully delivering the medicine. The new prototype would need to overcome several hurdles before it's ready to be tested in humans. However, in the drug delivery experiments, some rats were also given uncharged implants laced with anti-inflammatories, and their temperatures dropped, which suggested some passive drug release. The team also has not mastered turning the device on or off. It stops working only when the rate runs out of power. Future research will also need to address the device's size and full biodegradability. At present, the size of the system is still relatively large and contains a small rectifier module which converts between AC and DC, and stability needs to be further improved, Lan said. There is still a certain distance to achieve real biomedical applications, they said. And this is by Kumar's Afifi Sabit on Life Science. Please leave your comments. Thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.